Aloha, everybody. We are going to be doing the next assignment in the CPM book. I want to remind you that if you log into your ebook, you will also have all the problems that you would normally have in your textbook, right? Um, and that's an old one. And they have tools for you that are sometimes helpful, sometimes not so much. And they have hints. So if you ever get stuck on anything and I haven't made a video, go check that out, or sometimes check it out anyway. You might be given things that I didn't really help you with. Okay, I also want to remind you these methods and meanings. This is where we'll often teach you how to do things that we're doing in that chapter or other chapters. These are things that you should probably copy into your math folders. Be good to have. This one, maybe even science folder. We're doing most of the graphing and stuff in science. So it shows you how to do a histogram, shows you how to do stem and leaf plot, which, ooh, this assignment we have a stem and leaf plot. So hopefully we know how to do that. Anyway, this is lesson 2.2.1. Again, the very first thing you're always going to do, and you could time me, see how long it takes me, but usually about 30, 40 seconds, you're doing the perfect heading. Capitalize your first and last name. Always put the date. What's today? The 22nd, 2020. And your teacher's name and class period. Okay, and then if it's stuff out of the book, go ahead and put the problem numbers that you're doing, or maybe the lesson. Used to put the page. This is lesson 2.2.1, and if you want, you can put the problem numbers too. These are just weird numbered problems. 2-24 through, I put a big arrow. Usually you just put a little dash, 2 through 24, but the way these are numbered, it's a little bit more difficult. So through dash 2.28. Okay, boom. Would that take me? Yeah, about 45 seconds. A lot of talking and then doing some extra stuff. First problem is 2-24. And again, I would like for you to, at the very least, put that right parentheses around that. Some people are circling the problem number and then go do the problem. This has an A and a B, and this has a picture. It has a picture of a triangle, and that triangle is what's called an equilateral triangle. Means all three sides are the same, and it's broken into a triangle and what's called a trapezoid. Okay, and what's going on with that? If you were in class, if you go back a page, you see we probably would have had these little puzzle pieces, pattern blocks is I think what they call them. You might have seen these in previous grades, but these little triangles are green, the big hexagons are yellow, the diamonds or rhombus. That's four equal sides, parallelogram, four equal sides, like a square, but doesn't have right angles. That's a blue and the red trapezoid. And these all fit. You get two trapezoids fit into the hexagon. You get three of these blue rhombuses fit into the hexagon and six of the triangles. So I went ahead and colored in. This is a book that had some stains in it, had some pages ripped out. So the librarian gave me this one. The kid had to buy a new one because they turned it in such damage. So I went ahead and colored in what the problem says. Okay, it says it's made up of, the large triangle is made up of a little green triangle and a red trapezoid. And I went ahead and drew it in like that and colored it in. Don't do that in your book. I don't want to get in trouble. Okay, so the first question is, what is the area of the entire shape if that green triangle has an area of 1 square centimeter? Good question. When I look at that, what can we do? Well, if you have the pattern blocks and a bunch of these green ones, you can put them and see how many of these green ones would fit there. And you would notice that you could put 3 of those triangles to make that trapezoid and that one on top. So if the one on top equals 1 square centimeter, what's the area of the whole thing? Well, 1, 2, 3, 4. 4 square centimeters. And again, you can write it like that. You can write 4. Remember, we're learning that to the second power means squared. So you could do it like that. okay? Or you can spell out the word, okay? So A, I'm gonna write, that's 4 square centimeters. Go to B, and the question is, what is the area of the entire shape if the red trapezoid has an area of 1 square inch? Now they're saying all three of those together make 1 square inch. What's the area of this, all three of those, and this next one? Think about it, okay? And please, don't just copy down the answers. Every once in a while when I ask the question and I draw the picture or give you a hint, press pause and try it yourself first, okay? You wouldn't pay someone to exercise for you at the gym. You don't get anything out of it, right? So make sure you're not just copying. You get more if you think about it, even if you don't get the right answer. In fact, probably more if you don't get the right answer and then find out what the right answer is. You learn even faster that way. So what's the area of the whole thing? Well, if this whole thing, 3 of these makes 1, then one of those is like 1/3, right? So really what I have is 1 and 1/3 square inches, or 1, 2, 3 thirds makes 1 whole. Some people might want to write it as 4/3. It's the same thing, square inches. Okay, pretty interesting problem. I'm wondering how many of you got that. That was a tough one. Okay, tough puzzle problems. I love puzzles though. All right, now we have this shape here. And let me see, it is 7. So 1, 2, 3, 4, 5, 6, 7. You have graph paper, you're lucky. So I got to sort of eyeball. Looks like it's 3 wide at top. So I'm going to go ahead and divide that into 3 columns. Go ahead and go over these lines. But that's not the whole shape, right? It's 7 tall, but at the bottom, it's 5 wide, right? So how many tall is that at the bottom where it goes 2 more wide? Looks like it's 2 tall. No such thing as too tall, right? You can't be too tall. It's like being too rich, right? I'm playing with you. Yeah, the tall guy doesn't want to be called too tall. All right, so what's the area of that whole thing? Well, there's different ways of doing it. Some people would say, you know what, I'm just going to do this big rectangle here, and it's 7. It's not 7 times 5 though, right? 7 times 3, that's 21. And then add what's left. 1, 2, 3, 4. 25, right? Some people say, you know what, I want to do that bottom rectangle, and that's 5 wide and 2 tall, so that's 10. And then I want to do the top part, which is not 7 anymore. It's still 3 wide, but it's 5. So 3 by 5, 3 rows of 5, that is 15. And guess what? I get a 25 there. Okay, different ways of doing that. Some people might even pretend like this was a whole rectangle, all one giant rectangle that's 5 by 7, which is 35, and then subtract what got cut out. What got cut out? Well, 2 rows of 5, right? 10. And guess what? All 3 ways you get the same answer. Okay, doesn't matter how you did it, but that is going to be 25 square centimeters, and I'm going to write it like that. Okay, put a small box around the answer, big box around the whole problem. Okay, and I'm going to 2-26. Now, this one isn't estimating. Okay, and I have my choice. It's saying measure your desk and tell me, what would you use? What do you think? How big is your desk for the area? That's the space on top. Okay, well, 4 square inches looks like this. That's a square inch, right? I got the ruler out, drew 2 inches wide, right, by 2 inches tall. So that's 4 square inches. So desk is going to be much bigger than that. We know it's not A, right? Way too small. Square feet? Most pieces of paper are 8.5 inches by 11 inches, right? So a little bit longer than this, right? About 1 inch longer than that, and then 1 inch longer that way. So if you can imagine a square that sort of has that filled up like this, that's a square foot. 4 of those might make a student desk, right? Not the desk we have here in class, right? That might be upside down for you. Those big things that 2 people share, right? But yeah, 4 square feet. That looks like the best answer so far. The next choice is 4 square meters. Well, a door is 2 meters tall and 1 meter wide, so that's only 2 square meters. So yeah, it would have to be a pretty big desk to be 4 square meters, right? Maybe a kitchen table might be 4 square meters. It was a big one, right? And the last one, 4 square miles. We know that cannot be the answer either. So we're gonna say the best answer for one of those kids' desks, a single desk for one kid. We're gonna say a desk, and I'm gonna write a student desk is about. And remember how to make about? It's like a squiggly sign for the equal sign. 4 square feet. Probably a little bigger than that. Okay. Don't just write 4 square feet for your answer. Okay, because you can look at this all day long and you're not going to get any smarter. But if you say a student desk is about 4 square feet, every time you look at this, you sort of have an idea what a square foot is. Okay, or how much 4 square feet are, right? All right. 2-27, I'm going to get you started on this and remind you that on the 2-28, all you have to make sure you do when you add or subtract decimals or compare is stack them one on top of another and line up the decimals. Okay. The one thing you might also have to do, if I was subtracting, say I was subtracting 32.2 minus 18.82, okay, I'm going to stack them one on top of another. The first thing I write in the second number is the decimal. And then just like that worksheet we did, that pizzazz we did yesterday, okay, if you have an empty space there after the decimal, put a 0 in there so you don't get confused. Now I'm not going to bring that 2 down. I'm subtracting that 2 from 0. I'm going to go borrow, right? So make sure you do that if you need to, okay? All right, back to the front. 227. I have all of these numbers. 64, 87, 52, 12, 17. And what they want me to do is they want me to copy all those numbers and into a stem and leaf plot. They've started the stem and leaf plot, okay? And it just looks a little strange to me. I don't know what that 7 is going. What's going on with that 7? I think that, oh, I know what happened. Okay. So you take all these numbers. To make your stem and leaf plot, it helps to put those numbers in order. So I'm looking at these numbers, and it looks like 12 is the smallest. I'm going to put the 12 first. Then it looks like 17. And then what do I have next? Any more in the teens? How about in the 20s? There's a 23. Any more in the 20s? No. How about the 30s? No. Oh, there's one. There's a 34. Any in the 40s? I see a 45. How about in the 50s? 52. Oh, there's two 45s. Oh, good catch. 52. Anything else in the 50s? A 53. And then how about the 60s? I got a 62 and a 64. Any more in the 60s? I don't see. How about the 70s? 76, 77. 80s, 87, 88. I think I'm done. I'm going to double check the number that I have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 2, 4, 6, 8, 10, 12, 14. Whoops, I'm missing one. I'm going to have to go find that. Okay, and then I'm going to make my stem and leaf plot. And what do you do for the stems? That's the ones place. Okay, so I have a 1, and to represent a 12, I'm just going to put the 2 there, and the 17, I'm going to put the 7 there. They already did that for me. Now for the 20s, I got to go 23, so I'm going to put a 3 there. Okay, now I need to go find which number I missed. I couldn't cross them out. Maybe I'll do it lightly in pencil. But that's how you make your stem and leaf plot, right? They've already helped you by putting the stems all the way down through 9 to represent 90s, 80s, right? You're going to finish that, and then the rest of the answers will be presented to you tomorrow, okay? This should get you started. If you get stuck on anything, come to your afternoon Zooms and get help from your teacher, okay? And otherwise, I wish you luck, and I will do the other one tomorrow.